Hello, this is Dr. Nair with chapter 6. We are going to talk about some organic reactions. To understand the organic and biological chemistry, it is necessary for us not only to know what occurs during a reaction, but how and why these chemical reactions takes place. So first we will look at some kinds of organic reactions. And in general, there are four main kind of organic reactions that we come across. They are the addition reactions, elimination, substitution, and rearrangements. Okay, so we will look at each one of them separately with each one with one example. And the first one is an addition reaction where two reactants can add together to form a product. Okay, so we will have nothing left over. We will have just one product here. So for example, in this here we see ethylene reacting with HBr, and the double bond has opened up where the hydrogen and the bromine has added on to the pi bonds. This is an example of an addition reaction. The next one is elimination, where you can see that it's kind of opposite of addition reaction, where one single molecule is splitting into two products. Okay. Here we have again ethanol, like an alcohol molecule. In the presence of an acid catalyst, it is forming alkene, and water is the side product. So the next one, third type of reaction that we usually come across is a substitution reaction, where two reactants, they can exchange parts of their molecule to form new products. For example, here the hydrogen in methane is replaced by chlorine, so it's a substitution reaction, and then you form chloromethane and HCl as the side product. Okay, and then finally we have a rearrangement reaction, where a single reactant undergoes a reorganization of bonds. So you are not really reacting anything here, but what happens is maybe the product is a more stable form of the molecule, therefore rearrangements can occur within the molecule to give another isomeric product. Okay, so these are the four main kinds of reactions that we come across. We can look at a couple of examples to see if we can figure this out, of identifying different types of reactions. So the first one is showing a compound methyl acetate, which is adding on to a or reacting with water in presence of acid catalyst to form products. So here if you look at what has happened is the OCH3 part of the molecule, this part is substituted by the OH part of water, right? So this definitely is going to be an example of a substitution reaction. Now the next one, if you look, this is ethanol, and then what is happening here is a water molecule is being removed, and then we are forming double bonds. So from a single molecule you are forming two different molecules. So this is an example of elimination. The next one at the bottom is where you can see that the double bond is opening up, and you are adding a small molecule like HBr with only one product and nothing else being formed. So this is an example of an addition reaction. Okay. We can do maybe one more before we move on to the next part. Okay, here say for example I have CH3Br plus KOH to give CH3OH plus KBr. Okay, so the question is, can you identify what type of reaction is it? Is it an addition, substitution, elimination, or rearrangement? We can identify this as a substitution reaction. Why? Because the Br here in the first molecule is replaced by OH, it's substituted by OH to form the products. So this is an example of a substitution reaction. Another example, say I take a alkene, okay, alkene like this, and react it with hydrogen, right? React it with hydrogen, H2, and we get formation of ethane from ethylene. So we have the hydrogen atoms attached to this carbon atom. Maybe we can put some color here, so we can put this as H2 and say the two hydrogens are attached here. So what has we have seen that the double bond now opens up, right? The double bond opens up and you add the two hydrogens to it. So this is an example of a addition reaction. Say I have a reaction like this, where I take this molecule and change it into this, right? So here we see that an alkene, where the double bond was between the carbon 1 and carbon 2, now the double bond is between carbon 2 and 3 in the product. So here what we have done is we haven't reacted it with anything. Maybe this takes place in the presence of a catalyst, okay? So this reaction only changes from one form to the other. It's an isomeric product, so this will be an example of a rearrangement reaction. Okay, so generally rearrangement happens when the product is structure is more stable than the reactant. So here this double bond in the between the C2 and C3 is more stable than the one between C1 and C2. Okay? So these are a few examples, and maybe you can practice some more regarding identification of organic molecules. Now, the next step is we talk about, now that we have looked at different kinds of reaction, let's see how they actually occur. Okay, so we call that as a mechanism, a reaction mechanism. The mechanism of a reaction helps us to understand what really, like how the chemical transformation takes place, which bonds are broken, which bonds are formed, and a complete mechanism to go from a reactants to the products. Okay, so we look at different steps to go from the reactant to the product. So all the reactions occur with bond breaking. Okay, so we have bond breaking and bond formation. The bonds from the reactant break to form new bonds in the product. Okay? So this breaking and formation can happen in different ways, and we can classify these mechanisms as either happening in different steps, okay, or they can happen, all the steps can happen in together. So then we call that as a concerted reaction. Now let's look at different steps that can occur in a reaction mechanism. So bonds can break or form in two different ways, either in a symmetrical manner or in an unsymmetrical manner. So here we are looking at an example where there is a bond between A and B, and the bond is because of two electrons being shared, and then if both these atoms A and B have equal electronegativity, then both can take one electron each, and this type of bond breaking is called as a symmetrical or a homolytic bond breaking. And what ends up is in the formation of intermediate products, which are called as radicals. Okay, so a species with a single electron is called as a radical. On the other hand, if you look at the second example, because of the difference in electronegativity between the A and B, B being more electronegative than A, the pair of electrons are carried away by B, as a result of which A gets a positive charge and B gets a negative charge. Okay, so this unsymmetrical bond breaking results in a polar reaction. Okay, because we have created poles now, a positive pole and a negative pole, and this is another way by which bonds can break. Just like bond breaking, we can form bonds too, where two radicals can combine to form the product, and that will be a symmetrical bond making, or the unsymmetrical bond making can happen where one reactant donates electrons to the other reactant to form the product. Okay? So let's look at it one more time, where let's take another example here to illustrate this. So for example, if I have a chlorine molecule. Now chlorine, both the Cl atoms are same electronegativity, right? So when this bond breaks, okay, when this bond breaks, then each chlorine can take one electron each, okay? So it would result in what is called as a radical, right? So when this breaks, we get two chlorine radicals. Now, if you have paid attention, you can see that the arrows which I have drawn are half arrows. We call them as fish hook. Okay, that's because each of the atom takes only one electron out of this shared pair, right? So we draw this as fish hook. Okay, so half arrows. On the other hand, if I had a molecule like HBr, where Br is more electronegative than hydrogen, then these both electrons can be taken up by Br, and this would result in a polar reaction, polar bond breaking, where we get an H plus and a Br minus, because Br took up both the electrons from the shared pair. Okay? So here we will use full arrows. So see the difference in a polar reaction. This is a polar reaction. You will be drawing full arrows, and in a free radical reaction, you will only draw half or fish hook arrows, okay, which indicates that only one electron has been transferred from that shared pair. Okay, so next, this slide again illustrates the same thing which I just talked, that half head or fish hook arrows indicate what are called as radical reactions, and complete full head arrows indicate we have a polar reaction, okay, polar process. Now, in radical reaction, these are not as common as the polar reactions, but there are a number of biological pathways which do follow these radical mechanisms. So the way a radical can be formed, these are different examples illustrating how the radical can be formed. It can be either when there is a single radical that is present, and radicals are really reactive species because they have unpaired electrons, so they are always on the lookout for being paired. So they can actually break apart another molecule, as a result of which they can abstract a radical, and then a new radical can be formed. Okay, this is one way by which radicals can react. Another reaction that is when a radical can add on to an alkene. Okay, so in this manner you can see that the double bond of the alkene, one of the bond breaks and the radical is paired now, and it forms a bond here, and the other carbon atom gets the other radical. Okay, so this is another way by which radicals can react, and this is an example, a good example for us to understand a complete mechanism which happens through the free radical mechanism. Okay, all right. So let me use a different slide here in order to explain this. So if we take the overall reaction, which is a halogenation of alkanes, that's a good example for us to illustrate the free radical mechanism. So we can write this as halogenation of alkanes. Halogenation means reacting with halogens on alkanes. Halogenation of alkanes. So let's take the very simple alkane, CH4, which is our first alkane in our series. and react it with chlorine, Cl2, and the product would be, one of the product would be CH3Cl and the side product as HCl. Okay, it's an industrially useful radical reaction, and this is actually a substitution reaction. So if I draw this out with bonds, you can see that the hydrogen in methane has been replaced by a chlorine. So that's why it is a substitution reaction. Okay, one of the hydrogen is replaced by chlorine. This reaction is actually not very useful because generally this reaction does not stop by formation of one product. This reaction can continue where every hydrogen atom in the methane can be replaced by chlorine. Okay, so in addition to this product here, we can also get a product where two of the hydrogen atoms are replaced and you get the dichloromethane, or you can have three of the chlorines replaced, three of the hydrogens replaced with chlorine, and that gives you what is called as chloroform, CHCl3. This is a reaction compound called as chloroform. Or you can have all the hydrogen atoms replaced by chlorine, which gives you the compound called carbon tetrachloride. Okay, so this reaction is generally not very useful because you end up forming a number of products. Okay, but however, it is still a good example for us to illustrate free radical mechanism, as well as how this is one of the reactions that methane shows, because methane is generally a very unreactive compound. It's a saturated alkane. So one of the few reactions that alkanes show is halogenation. Okay, so you can either react it with chlorine, bromine, or iodine, and this is actually a good example for us to illustrate the free radical mechanism. So let's analyze how the free radicals are formed while this reaction is happening. Actually, one thing I forgot was this reaction only happens in the presence of light. Okay, light is kind of something to initiate this reaction. We need light. So let's do the complete mechanism here. Since it is a free radical reaction, there are three kinds of steps that will happen. Okay, the steps in a free radical reaction are initiation. These are the steps. Then propagation, and finally there is termination. These are the three steps that takes place in the free radical mechanism. So initiation, the light is necessary to break the weak chlorine-chlorine bond to form chlorine radicals. Okay, so in the first step, which is initiation, the light breaks apart this bond. It's a weak bond between the two chlorine atoms. Sometimes light is written as h nu. Okay, if you remember from Chem Chem, h stands for Planck's constant, nu is frequency. Okay, so this is just light. Okay, that's how we represent light. And what happens is each of the chlorine atom takes one electron from this bond. So remember, we put the fish hook arrow and you get two chlorine radicals. Okay, so see there's one unpaired electron here. You can also represent this just like chlorine radical. Okay, this is also fine because the others are all paired, etc. So one unpaired electron is present. Or you can write it like this: two chlorine radicals. So that's my initiation step. The next one is propagation. Propagation, where once the radicals are produced, they are so reactive that they will collide with a methane molecule in the reaction mixture, and they will abstract a hydrogen atom to give HCl, and a new radical is formed, which is the methyl radical. So we call this as propagation because every time this reaction happens, you get a new radical on your product side. So let's see how we can illustrate this. So the chlorine radical from our first step, which again I'm representing just with one electron. To be more correct, it has to be represented with all the pairs too, but I'm just, for clarity, I'm just putting one electron because that's the one that is instigating the formation of the new radical. So this is my methane. And this chlorine radical abstracts the hydrogen, again only half the arrow, and this other arrow can be drawn to this. And let me redraw this with a little more space here. Okay. So the chlorine radical, and this is my methane. We have to show two arrows. So this one, half arrow coming, this half arrow coming from here. Maybe I'll go ahead and draw the other electrons to make it more correct. Okay? So this bond breaks, but only one electron is needed because we already have one electron here, and then the other electron is placed in the carbon atom. So what do we get? These both are happy, the hydrogen and the chlorine, so we get HCl as one product, plus we get a new radical because carbon here is short of the other electron, so it has got only one unpaired electron. It's a methyl radical, okay, CH3 radical. So this is an example of a propagation step. Actually, there can be one more. We can show this propagation in with another example. So maybe this methyl radical, once it is formed, which now I can represent as CH3, okay, it can induce the breaking of this chlorine-chlorine bond. Now in our reaction vessel, we have plenty of chlorine molecules, so maybe this can initiate the breaking of another chlorine molecule into a new radical. So maybe you can get this as my product, CH3Cl, because these both combined, and then a new radical is formed, which is my chlorine radical. So as long as there is a radical formed on the product side, they will be termed as propagation step. Okay, so far we did two of them: initiation, which is required light to start the reaction, and we got the chlorine radical. The chlorine radical collides with the methane molecule to form HCl as one product, and then a new radical, CH3 methyl radical, is formed. This is my methyl radical. And the next, another propagation step may be this: methyl radical can instigate this chlorine molecule to break apart homolytically, where it needs just one electron from the chlorine, right? Because it already has one, and gives the other electron to the other chlorine atom, and then we get a new chlorine radical. Okay. All right. So these are the two propagation steps, but we need to complete it by the third step, which is my termination step. So the termination step is where two radicals combine to form the a product, but no new radicals are formed. Okay, so that is a termination step. So that can happen when two radicals collide and to form a stable product, but there is no new radicals that are formed. Then the reaction cycle is broken and the chain is ended. Okay? So such termination steps occur in the following manner. So we can see maybe the reaction vessel, there was a methyl radical, right, which can collide with maybe a chlorine radical. Can show the reaction like this with two half arrows, and it forms CH3Cl. So the reaction just stopped, right, because we have no new radicals formed. Or maybe one chlorine radical can go back and combine with another chlorine radical to give more of Cl2. Or maybe two CH3 radicals can combine to form a product like ethane, right? Two CH3s means C2H6. So these are all reactions which are illustrating our termination of the last step. So this termination steps are where it's not very frequent, because the concentration of radicals in a reaction at a given moment is very small, and so the likelihood that two radicals will collide is also very small. Okay, but we do show all these steps when we illustrate the free radical mechanism. Okay? And these are more common in biological reactions, like synthesis of prostaglandins. You can take a look at some more examples from your textbook. But in our next video, we will talk about the next type of reaction, which is our polar reactions.